So in the previous class, we had a discussion about the ripple factor and efficiency of half-wave rectifier. So here, the half-wave rectifier, which is going to rectify the negative cycle or positive cycle based on the diode connection in the circuit, we get rectified outputs. And we have defined some definitions with equations with respect to the ripple factor and the efficiency of the half-wave rectifier. So let us continue with the next concept, it is full wave rectifier. So the full wave rectifier, there are two types. One is center tapped full wave rectifier, another one is bridge rectifier. The center tapped, or generally it is known as two diode full wave rectifier. If you look at the diagram, it has uh, four, or you will say five components. One is input AC supply, another one is a transformer. Based on the requirement, we may use any one. It is among step down or step up or the coupling transformer. Okay. Then the secondary windings of the transformer are connected such that here the name is the center cap, because in the transformer at the middle of the secondary, we are going to consider that the middle secondary, it has a common terminal. Okay, so it has three terminals: center tapped, transformer. So middle one is the common terminal. Okay, here we are going to consider two diodes in the circuit. The secondary of the transformer in center tapped transformers. We are going to have two halves, first half and second half, the secondary windings of the transformer. Okay, you can observe here there are two halves, and here the center one, it is a common terminal, or you may say it is a ground terminal in that secondary winding. So in the first half, we are going to use one diode, okay, and we are going to connect the RL resistor to the that diode in series, and another terminal of the resistor, it is connected to the common terminal of secondary. Okay, another half. Okay, another half, the output wire, what we have considered, it is connected to another diode, okay, and the same diode, another terminal is connected to the load resistor RL. So this one is the schematic diagram or the circuit of center tapped or two diode full wave. So here what is going to happen with the transformer? For positive cycles, one half is going to work. What another half, it will be in half state. Okay. So what is going to happen with respect to this circuit? For first half, diode D1 is going to conduct, and for second half, diode D2 is going to conduct. So similarly, we can observe the waveforms with respect to the performance of this circuit for positive cycle of the V in. So V in is nothing but what? It is the secondary voltage of the transformer. Secondary voltage at the secondary winding of the transformer. It will be in first half section or second half section. Okay. So for V in, for positive cycle, one diode D1 is going to conduct. For second half, that is nothing but for V in second half, diode D2 is going to conduct. So we are going to observe in both positive and negative cycle of the input voltage for both diode D1 and D2, the load resistor RL is going to have the current passing through it. Therefore, we are going to observe output is having all positive voltages. All positive voltages. So if you go for the it employs two diodes and a center tap transformer. The AC signal to be rectified is applied to the primary of the transformer and the AC output is taken across the load RL. Then, if you go for the working phenomena of this circuitry, okay, so during the positive half cycle, so end X is have positive polarity and end Y is have negative polarity. So this makes diode D1 forward biased and thus a current I1 flows through it and load resistor RL. Diode D2 is reverse biased and the current I2 is 0. So in this explanation, what they are talking about here, diode D1, I1 current is going to flow and the diode D2 is going to conduct I2 current. Okay. So what is going to happen with the positive half cycle of the input? The X terminal of the secondary winding of transformer has positive polarity where Y is going to show the negative polarity and the center of the secondary winding, it is a common terminal. So what is going to happen? The diode D1 anode, it is connected to positive polarity of the power supply and the negative is connected to common terminal. Okay. So what about the D2? The anode terminal, it is connected to negative. Hence, it is not going to conduct any current because it is in reverse bias condition. Obviously, diode D1, the anode is connected to positive polarity of the power supply. Therefore, it is going to conduct the current. Hence, the current I1, it is going to flow through this load resistor RL. Even though at this terminal, you can observe the current is going to split into two parts here, and one is towards diode D2, another one is towards load resistor RL. So as diode D2 it is in off condition, no current is going to flow in this direction. Obviously, the current it is going to flow through this diode D1, load resistor RL, and reach ground terminal. Okay. So what is going to happen? So because of this one, so for all positive, so we know the rectifier this thing. So we have the input voltage is equals to output voltage. For V in diode D1, it is going to perform, diode D1 is going to perform its operation as a forward bias condition. Therefore, the voltage across RL, it will be available with the amplitude values of V. Okay, between the duration 0 to pi, or we may say generally positive cycle of the input. So what is going to happen with the negative terminal or negative cycle? The negative half cycle of the input, end Y is positive and end X is negative. Now diode D2 is forward biased and thus a current I2 flows through it and load resistor RL. Diode D1 is the reverse bias and the current I1 will be 0. So therefore, what we are going to observe it is okay. So what is going to happen during negative half cycle? The Y terminal becomes positive polarity and X terminal becomes negative polarity. So therefore, what is going to happen if I go for removing these let's say erase all these things. So what is the previous condition for positive cycle? Diode D1 is going to conduct, hence output will be there across RL. Okay, so what is going to happen for negative cycle? So Y terminal is going to show positive polarity and X terminal is going to show negative polarity. So as we observe the position of these diodes D1 and D2, D1 anode is connected to negative terminal. Hence, it is in reverse bias condition. So what about D2? The anode terminal is connected to positive of the power supply. Hence, it is going to start conducting due to the forward bias condition of the diode D2. Therefore, the current I2, what we say, okay, which is flowing through this diode D2, and it is going to go through this load resistor RL. Even though at this point, at this node, there are split in the current of I2. So no current is going to flow towards diode D1 because diode D1 it is in the off mode. Okay. Therefore, the load resistor is going to conduct the current during negative cycle of the input. Therefore, the output it is also having the positive polarity, positive values due to the diode D2 under forward bias condition. And this phenomenon is going to continue for all positive and negative cycle of the inputs. Okay. So any doubt in this center tabbed full wave rectifier? So full wave nothing, half wave or full wave. The difference is in the full wave we are going to get the both means the complete signal will be there between 0 to 2 pi. So what is going to happen in the half wave? Only half duration will be there. It will be 0 to pi or pi to 2 pi. Only one cycle will be there at the output side. And most of the times, this one is not, they are not going to ask this center tap the full wave rectifier. Maximum times they have asked the next concept, that is bridge rectifier. So here it is going to be designed using 4 diodes. The center tap is going to use only 2 diodes. The bridge rectifier is going to use 4 diodes. So if you open all the rectifier circuits, okay, in any electronic good, you are going to observe the first converter from AC to DC. It is going to be used as a bridge rectifier circuit with 4 diodes. So ಯಾವುದೇ electronic code where you are converting the power, okay, the analog to digital, or you are reducing the signal AC to DC, you are converting there, you are going to observe the bridge rectifier. So bridge rectifier circuit, it is going to use 4 diodes, D1, D2, D3 and D4. Okay, ನೀವು ಯಾವುದೇ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಗೂಡ್ ಓಪನ್ ಮಾಡಿ ನೋಡ್ರಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಿಮ್ದು LED ಬಲ್ಬ್ ಮನೇಲಿರೋದು, LED ಬಲ್ಬ್ ಓಪನ್ ಮಾಡ್ರಿ, where the from the main supply ಅಂತ ಏನು,
Sir, sound is breaking, sir.
Obviously here we are going. Now it is audible.
Break
audible,
sir.
Not clear, sir.
Then let's set the device settings. Now
No, sir.
and now is it okay?
Yes, sir.
Fine. So let me go for this one. Here in the bridge rectifier, what we are going to use it is 4 diodes. So if you open any LED bulb or the regulator, what you are going to use in your mobile phone, okay, mobile phone charger device, ಅದನ್ನು ಓಪನ್ ಮಾಡಿದ್ರೆ ನಮಗೆ ಕಾಣಿಸುತ್ತೆ ಒಂದೇ ಫಸ್ಟ್ ಸ್ಟೇಜ್ ಯಾವುದು ಮೇನ್ಸ್ ಇಂದ ಏನು ಬರುತ್ತಲ್ಲ, ಮೇನ್ಸ್ ಇಂದ ಬಂದ ತಕ್ಷಣ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಅಬ್ಸರ್ವ್ ದ 4 diode circuit. So that is what your bridge rectifier circuit. So here we are going to use once again the concept of AC supply, then the transformer. Based on the requirement, we are going to use any transformer. It may be step down, step up, or coupling transformer. And we have two ends for the primary, secondary of A and B. Then the diode circuits of these 4 diodes. It is such that you can observe carefully the anode and anode. Okay, anode and anode of 2 diodes are connected, short circuited. Anode and anode, they are connected. Let's say example D4 and D3. Anode terminals are connected. If you go for D and D2, cathode are short circuit. If you look at the circuit diagram says that the anode of 2 diodes are connected. Cathode of another 2 diodes are connected. Okay. Then this bunch, anode connection, 2 diodes, and the cathode connected, another 2 diode bunch, they are connected such that the circuit will be complete. So D1 anode is connected to D4 cathode. Similarly, D2 anode is connected to D3 cathode. Okay, and here where you are going to observe the anode cathode connections of 2 diodes, where you are going to observe the anode and cathode terminal of 2 diodes. We are going to supply the main input signal. Okay, the main input voltage is connected to the 2 lines. ಯಾಕಂದ್ರೆ ನೀವು anode cathode ಒಂದು diode 2 diodes ಇದೆ, ಇನ್ನೊಂದು anode cathode connection another 2 bunch. Okay, so those 2 bunches considered as input to this diode circuit. So what about output from this diode circuit? Where the 2 lines, the 2 diode bunch, that is anode connected this line, and cathode connected this line. So these 2 are considered as output from the circuit. So you are getting the thing. So how the circuitry? Is my voice is clear?
No, sir.
No, sir.
No, it is not clear. Okay, let me leave now. Now, is it working? So now I hope voice is clear. Is my voice is clear?
Yes, sir.
Yes, sir.
Yes, sir.
So for this one, once again, let me repeat these things. How the bridge rectifier connection will be. So here it is transformer secondary, where two lines are there from the transformer secondary A and B terminals, and these two terminals are connected to the diode circuit. And before going to that connect, we concentrate on how diodes are connected together. So we have 4 diodes. Let me take one bunch, 2 diodes, a combination of 2 with the anode and connected together. So if you look at this diagram, the diode D3 and diode D4. So these two diodes are connected such that the both anode and anode terminals are going to be short circuited. Then another 2 diodes, what we are using. So those 2 diodes, cathode are short circuited. Let me say in this diagram, diode D1 and D2, the cathode terminals are short circuited. So this is one short circuited line, and this one is another short circuited line. So these 2 short circuited lines are considered as the output lines. They are considered as output lines. So at the output, obviously, we are going to use one load resistor RL. One load resistor RL. Okay. So here, next, where to give the inputs. So input will be given. So we have the 2 resistors, anode connected, and 2 resistors, cathode connected. And they are considered as output lines. So where to give input? So input are given to the anode cathode terminal of the combination of these 2 bunches. So anode and cathode terminal. For example, one line, the line, short circuit between D1 and D4. D1 anode and D4 cathode. They are short circuited and they are considered as one of the input line. Similarly, diode D2 and D3. Diode D2 anode and diode D3 cathode. They are short circuited and they are considered as another input line. Okay. So 4 diode bridge rectifier circuit. And what is going to happen with respect to input? So look at these inputs. So input will be what? Input, it is from A and B terminals. So this input I am going to apply. This input signal I am going to apply. So what is going to happen? So when I apply this input signal, that is nothing but positive cycle and negative cycle with some amplitude voltage, plus or minus some Vin voltage. So here for positive cycle, A terminal of the secondary of transformer is going to act as positive polarity and B is going to act as negative. Similarly, for negative half cycle, the A will be reversed and B will be polarity compared to previous states. Okay. So during this positive cycle, which diode is going to conduct? Okay. For negative cycle, which diode is going to conduct? That is the concept. So if you go for the during positive half cycle, end A is positive and end B is negative. Thus, diode D1 and diode D3 are in forward bias condition, and D2 and D4 are in reverse bias condition. So what is going to happen? So in for positive cycle, obviously the load resistor is going to conduct the current. Hence, we are going to observe the positive output voltage. It is due to diode D1 and D3 in forward bias condition. So yes or no? You just observe. You go for this one. Let me remove these pointers. So what is going to happen? So if you go for this one is positive terminal and this one is negative terminal. If you say it is positive, yes, this is plus polarity and minus polarity of the power supply. Now tell me, what about diode D1? The diode D1 is facing positive polarity, anode is facing positive polarity, and the diode D4 cathode terminal is facing the positive polarity, isn't it? So diode D4 cathode is facing positive polarity and diode D1 anode is facing positive polarity. So among these two, diode D1 is forward bias and diode D4 it is in reverse biased. So what is going to happen? Whatever the current, it is going to pass through this diode D1. Now it will come to this node. So what is going to happen? So diode D2 negative, it is facing positive polarity. Okay, so therefore it is in once again reverse bias condition. So no current is going to flow through this diode D2. And the current, obviously it has to pass through this load resistor RL. Then once again it has to come to this point. So initially diode D4 is obviously it is in the off state in the reverse bias. Hence diode D3. So this terminal is positive polarity. So and this one is anode terminal of D3. So these two are going to make what? Diode D3 in forward condition. Therefore, the current is going to pass through this D3 and reach destination. Okay, so this is the path for the current supply for positive cycle of the input. Where diode D1 and D3 are going to be conducted and diode D2 and D4 will be in off state. Now look at the, let me remove, look at what happened during negative half cycle. So end B is positive and end A is negative. Thus diode D2 and D4 comes under forward bias condition while D1 and D3 are in reverse biased. Now the flow of current, obviously it is going through this forward bias diodes, diode D4 and D2 through RL. Therefore, the output will be there across RL. Hence, we are going to observe between negative cycles, output will be there. Okay. So there it is due to what? Due to diode D2 and D4, the negative cycle. So if you want to observe, you can observe here. During negative cycle, B terminal is positive. So this diode D1 anode is connected to negative of the power supply diode D1, which is in reverse bias condition. So what about D4? Okay, or before going to D4, let me go for this positive terminal. So this one is positive terminal of the input here. What is going to happen with the D2? So D2 anode is connected to positive power supply. This one is into conductor. D3 anode is connected to positive of power supply, and D3 is in the reverse bias condition. For the cycle, it is going to begin from B
Your voice
terminal of
break
the
out.
secondary winding. Yes. So maybe it is due to the systems what I am using. Or network issue at your end. Issue at your end or network issue at my end. So here. And no need to worry. So all these videos will be there in the YouTube channel once I give your assignment work for this week. Okay. So even if it is a disturbance, network issues, so we want to resolve those things. So let us answer it. So when we begin from negative cycle, the B terminal and all it is to pass through this D2 and it is going to pass through this load resistance to this node. Obviously D3 is it is in reverse bias condition. Therefore, it is going to pass through this D4, then it is a destination. Okay, this is the flow of current in negative cycle. So it will be any cycle, diode load resistor RL is going to conduct the current, hence output will be there across load resistor RL. So because of this diode phenomena, we are going to observe for positive cycle, output is there. For negative cycle, output is there. Okay. So this one is the bridge rectifier concept. We go for the overall full wave rectifier equations with respect to efficiency and ripple factors. So here the output DC current, what we are going to use, it is given by the equation output DC current, output side across through this node resistor RL, how much DC current will be there? It is 2 times of maximum current divided by pi. If you go for the power, the output DC power, it is CDC, which is equals to the IDC square into node resistor RL. So that is 2 times of Im by pi whole square into node resistor RL. Then if you go for input side, so input side we are applying the AC current, hence we are going to calculate the input current as the root mean square value. The root mean square value, which is given by the maximum current in the circuit divided by square root of 2. Then the input AC power, because the ripple factor and the efficiency. So to go for those calculations, we need these basic equations. Okay. There is no derivation for why the equation will be like this. So you are provided with standard equations. So the input AC power is given by the input AC power, it is the maximum current, that is root mean square value of the current IRMS into the 2 resistances which are going to be there at the input side. One is the diode resistance RF, another one is load resistor RL. So these two are, while current is passing through these components, we are going to observe what diode is there. Obviously, it has a resistance power RF and load resistor RL, and these are summed up because here we are going to use the series connection of diode and load resistor RL. Thus, the both resistances are added up. So it is the RF plus RL, the total input resistance into the current at the input side. That is Im by square root of 2 whole square. So if you go for the efficiency, it is given by output DC power to the input AC power. The efficiency of the bridge rectifier or a center tapped rectifier, or we may say full wave rectifier. Okay, so generally it is a full wave rectifier. We have 2 types. One is the center tap, and another one is bridge rectifier. So it is efficiency is given by the ratio of PDC by PS. So if you substitute the value, that is PDC. If you go for the ratio of PDC, 2 Im by pi square into RL divided by Im by root 2 whole square into RF plus RL. So I am leaving this calculation as an assignment. So in the assignment, you have to derive this one. Okay. So here I am not going for any mathematical calculation there because it is a simple calculation. What you need to do, PDC by PAC. So finally, you are going to get the mathematical equation. It is going to reduce to the efficiency for the full wave rectifier. It is 0.812 divided by 1 plus RF by RL. So if you consider the resistance, 2 resistances, the diode resistance and the load resistance. So comparing these 2 resistances, the efficiency will be maximum if RF is negligible as compared to RN. Obviously, it is a negligible thing because during the conduction, the resistance offered by the diode is negligible, or you may say it is a minimum value. So therefore, the minimum value divided by maximum value, what you are going to get. So it is once again the minimum value itself. Therefore, we are going to neglect that minimum part, the maximum efficiency from a full wave rectifier. You can observe it is 81.2%, which is double of half wave rectifier. Okay. So for ripple factor R, which is calculated as the ratio of AC current to the DC current, which is given by the square root of IRMS divided by IDC whole square minus 1. If you substitute these equations, IRMS, that is Im by root 2, and IDC, that is 2Im by pi, whole square minus 1, which is going to reduce. I'm not going to dealing with all these mathematical steps because it is a simple divide operation. Okay, with respect to two values. So the ripple factor, it is end up with R is equal to 0.48. So this one is the today's session, that is full wave rectifier. So what are the things we have observed? So we have observed the full wave rectifier. It is of two types. One is the center tapped, another one is bridge rectifier. So in the center tap, we are going to use a special transformer, that is having the middle secondary. It is a common terminal. Okay. So means the secondary of the transformer is divided into two halves. Then we had discussion about how this working phenomena of this center tapped full wave rectifier during positive half of the input and negative half of the input. So for the concept of the bridge rectifier. So the bridge rectifier, once again, during positive and a negative half cycle of the circuit. How the bridge rectifier it is designed? By using 4 diodes. Okay. Then concept of the ripple factor and efficiency of full wave rectifier circuits. These are the basic electronic circuits. What we are going to observe in all electronic goods. Okay, we need to convert AC to DC. Okay, but if you look at the waveforms, output is having both AC and DC. But we need a pure DC. So if you observe these things, the PDC at output side, the DC output power, there is a AC output power is also there. Okay, but we are not going to go through all those concepts in depth. But for your basic knowledge, we are going to have only the efficiency equation, the output DC power divided by input AC power. Okay, so having those equations, we come to know what is the efficiency and ripple factor of this circuit. Okay, but the output is having both AC and DC. So to convert or to get pure DC, we need to use another component. So what is that component? We will deal with that one in the next class. Okay. Till then, have a nice day. Thank you.
Sir. Sir.
Okay.
Sir, assignment ಬರೆಯಕ್ಕೆ ಕೊಟ್ಟಿದ್ರಲ್ಲ ಸರ್ ಆಸ್ ಇಟ್ ಇಸ್ ಸೇಮ್ ಬರಿಬೇಕಲ್ಲ ಸರ್ ಅದನ್ನ
as it is a ಬರೀರಿ ಬಟ್ ಡೋಂಟ್ ರಿಪೀಟ್ ಡಯಾಗ್ರಾಮ್ಸ್. ಡಯಾಗ್ರಾಮ್ನ ರಿಪೀಟ್ ಅದಕ್ಕಂದ್ರೆ ನಿಮಗೆ ಎಕ್ಸ್ಪ್ಲೇಷನ್ ಮಾಡೋ ಟೈಮಲ್ಲಿ ಈಸಿ ಆಗಲಿ ಅಂತ ಹೇಳಿ ಯೂಸ್ ಮಾಡಿದ್ದೇನೆ. ಸೊ ಡೋಂಟ್ ರಿಪೀಟ್ ಡಯಾಗ್ರಾಮ್ಸ್. ಓಕೆ
ಓಕೆ ಸರ್.
So it should be a ready-made notes for you. So ನಿಮಗೆ ನೋಟ್ಸ್ ಹೆಂಗ್ ಬರೀ ಅಂತ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ. ಸೊ ನಾ ಕೊಟ್ಟಿರೋ ಮಟೀರಿಯಲ್ನ ಮೇಕ್ ಇಟ್ ಅ ನೀಟ್ ನೋಟ್ಸ್. ಓಕೆ
ಸರ್ ಸಬ್ಮಿಟ್
Okay, sir.
ಎಸ್ ಪ್ಲೀಸ್ ಆಕಾಶ್.
ಸಬ್ಮಿಟ್ ಮಾಡಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ಐತಿ?
ಸೊ ಇಟ್ ಇಸ್ ದ ಡ್ಯೂ ಡೇಟ್. ಅಲ್ಲಿ ನಿಮ್ಗೆ ಗೂಗಲ್ ಕ್ಲಾಸ್ ರೂಮ್ ಓಪನ್ ಮಾಡಿದ್ರೆ ನಿಮ್ಗೆ ತೋರಿಸುತ್ತಿರೋದ ಡ್ಯೂ ಡೇಟ್ ಯಾವಾಗಿದೆ ಅಂತ ಹೇಳ್ಬೇಕು.
ಆಯ್ತು.
Okay. And my one side, from my side, there is a request that so whatever the information given by me, it may be in WhatsApp or it may be in Google Classroom, so read it thoroughly. Okay, neatly ಓದ್ರಿ ಅದನ್ನ from top to bottom. ನೀಟಾಗಿ ಓದ್ರಿ. ಏನಾದರೂ ಅದ್ರ ಮೇಲೂ ತಿಳಿಲಿಲ್ಲ ಅಂದ್ರೆ ಇನ್ನೂ ಕ್ವೈರೀಸ್ ಇದ್ರೆ ಯು ಕ್ಯಾನ್ ಆಸ್ಕ್ ಮಿ. ಓಕೆ ರೀ. ಸೊ ಅದು ಓದ್ಲಾರ್ದೇ ಇಮಿಡಿಯೇಟ್ ಕ್ವಶನ್ ಕೇಳೋದು ಇಟ್ ಇಸ್ ಒನ್ಸ್ ಅಗೇನ್ ಇಟ್ ಇಸ್ ಅ ಬರ್ಡನ್ ಅಟ್ ಮೈ ಸೈಡ್. ಯಾಕಂದ್ರೆ ನಿಮ್ಮ ಪ್ರಕಾರ ನಾನು ಒಬ್ಬನೇ, ನನಗೆ ನೀವು 33 ಜನ, ಓಕೆ 40 ಜನ, ಸೊ 40 ಜನ 40 ಕ್ವಶನ್ ಕೇಳಿದ್ರೆ ಆಬ್ವಿಯಸ್ಲಿ ಇಟ್ ಇಸ್ ಅ ಹೆವಿ ಬರ್ಡನ್ ಅಟ್ ಮೈ ಸೈಡ್. ಸೊ ಒಮ್ಮೆ ನಾ ಏನು ಕೊಟ್ಟಿರ್ತೀನಿ ಅಂದ್ರೆ ಸ್ವಲ್ಪ ನೀಟಾಗಿ ಓದ್ರಿ. ಓದ್ಬಿಟ್ಟು ಅದ್ರ ತಕ್ಕಂಗೆ ಫಾಲೋ ಮಾಡ್ರಿ. ಅಕಸ್ಮಾತ್ ಯಾವ್ದಾದ್ರು ಗೊತ್ತಾಗಿಲ್ಲ ಅಂದ್ರೆ ಯು ಕ್ಯಾನ್ ಆಸ್ಕ್ ಮಿ. ಓಕೆ ಓಕೆ. And no need to worry, it is the beginning. So it is not any huge concept or any huge technology it is used. It is a simple app what we are using. It is Google Classroom. And regarding this voice breaking and all those things, we are purely helpless from my end and your end also. Because from my side, everything is correct. My Bluetooth is working, device is okay. There is no issue with the concept. It may be network issue, which is unsolvable. Okay. So, but don't worry, notes will be there as well as videos will be there in the YouTube. So time to time free ಇದ್ದಾಗ ನೋಡ್ಕೊಂತ ಬರ್ರಿ. ಸೊ ನಿಮಗೆ ಈಸಿಯಾಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತೆ. Okay. So with these notes, we will meet once again in the next class. Have a nice day. Thank you.
Thank you, sir.